Okay, welcome to Algebra 2. This is Unit 3, and then underneath my head there, it says Lesson 1, Part 1. We are going to park ourselves in Lesson 1 for a while because what we need to cover is super important for all of the rest of Algebra 2. So just make sure that when you're looking up videos and your homework and such that you're paying attention to Lesson 1, Part 1, Part 2, Part 3, Part 4, however long we're in Lesson 1. I do have a guest lecturer this evening. This is Vasya. All right. So he's going to make sure that he is in the way as much as possible. All right, so what are the learning targets, success criteria for this particular lesson? Well, ultimately, the learning target is to solve quadratic equations graphically and algebraically. So this is a big target, how to solve quadratic equations, because we need to talk about what a solution is, what exactly are we looking for, and then go through different strategies for how to get there. And one of those strategies, the one that we're going to focus on, the algebraic strategy we're going to focus on, is factoring. Okay, and that by itself takes a little while to cover. So how will you know if you've met the learning target? Well, if you can solve quadratic equations by graphing, if you can solve them algebraically, and if you can apply them to solve some real life problems. And there are a lot. Quadratics are actually very applicable. Our benchmark over here is ma.192.ar.3.2. which is given a mathematical or real-world context, write and solve one variable quadratic equations over the real and complex number systems. That particular standard is going to go outside of this lesson, so we're going to be in that standard for a while. So key vocab and ideas, and I have a subheading here that says focus on what we're doing, not just how to do it. Sometimes if you're just focused on how to get that answer, but not the whys behind it and what it actually is we're trying to accomplish, then if I or someone else puts a little bit of a twist on the problem and they change the what, then your how doesn't work anymore. But if you focus on what we're trying to do, then I or someone else can make a modification to the directions and you'll be able to integrate in whatever other knowledge you have to be able to do that. So key vocab and ideas. These are the two key ideas. What are factors? So we need to know what it is. If we're going to spend several lessons on factoring and finding factors, we need to be really clear on what it is that we're finding. And then what are we doing when we factor? So when those directions say factor, what does that mean for you to do? And that can become confusing because when we factor, the directions are often going to say solve and not factor, or they'll say solve by factoring, and you need to know the difference between the two. So starting off with what are factors, okay? So what are factors? Factors, simply put, are things, and I really don't like using the word things there, but for the lack of a better word, they are things that are multiplied. Okay, so when we talk about the factors of something, we're talking specifically about things that are multiplied. So to give you an example, because that definition may or may not be specific enough for you, especially with the word things in there. So some examples using the number 12. So you've got the number 12 and maybe you're asked, what are the factors of 12? So what you need to do to engage that definition is you would need to ask yourself, what are the things that are multiplied that give me 12? And so you might think of, well, 1 times 12. Okay. Or some of you might be thinking, well, what about 2 times 6? That would also work. And then some of you might be saying 3 times 4. Now, some of you might be thinking about some other possible combinations, like what about decimals? What about fractions? What about other things? When we're talking about factors, particularly of a number, we're talking about whole number factors or integer factors. I should say integer factors, not necessarily whole number, but we're not talking about decimals and fractions. So for a lot of you, that's probably good news. And that would be an excellent question if you were sitting in class doing this lesson to ask, well, what about, something like, 12/5 times 5? Like that would be 2 things that multiply. Okay, and when we expand this out to quadratics, we're also in those cases not going to be considering things that like the fractions and the decimals. Okay, now what you will sometimes see here is that you might see like a statement like this. You could see 1, 2, 3, 4, 6, and 12 are all factors of 12. Okay, are all factors of 12. So you could say, you might hear someone say, well, 3 is a factor of 12 or 6 is a factor of 12. 12 is a factor of 12. And a prime number is a number whose only factors are 1 and itself. Now, when you see that, okay, you could see them listed as like a list, or you might hear one pulled out in isolation. So 2 is a factor of 12. But when you're factoring, your factors always come in pairs. Okay, so it's true that 2 and 3 are both factors of 12, but they're not paired together as factors of 12. So what are we doing when we're factoring? So you're looking at some homework, you're looking at the SAT, you're looking at a college entrance exam, okay? And the directions say factor, and then you see something, okay? What then are you being asked to do? And you'll notice that this is a noun and this is a verb, okay? So you've got the noun factors. Factors are things, but it's also a verb. So you are being told to factor. Okay. When you are factoring, you are finding the factors. Okay. Now, when you're factoring a number, okay, that's not a super common task. Usually, if you have to factor a number, you could be asked several different things, like including what's called prime factorization and so forth. We'll talk about that in a later lesson. When you're factoring a quadratic, though, there are only 2 factors. So you're not looking for multiple pairs of things. Sometimes if there's a GCF, you might have 3 factors. So you could have the GCF factor, the greatest common factor, and then the way the quadratic itself factors. So, all right. So let's go and take a look at how we're going to do this. And if you've got questions, so if you felt like this was a little bit muddy for you, what I'm going to encourage you to do is hang tough through the rest of the lesson and see if your questions don't get answered later in the lesson. But if they don't, shoot me an email or post on Teams and just say, I was watching the video lesson on this and I have questions about factors and factoring in this example and whatnot. Okay. So what method will we be using to factor? There are lots of different methods, and I've used different methods. Different teachers will feel very strongly about particular methods, and I have to pick a method to use consistently. So when I am factoring in class, when we're going over homework, this is the method that we are going to be using in class. If you know another method, and you can demonstrate to me that you know how to use it and it's you and it's not photomath doing another method, I am okay with you using another method, okay? But when we're talking about factoring in class, this is the method that we're going to use. we are going to be using something called an area model. And the reason we're going to be using that is because you are already familiar with finding area from your previous math classes. So it is a nice model. It's very visual. It's going to lay the factoring out in a format that I think is nice for students to have. And it also ties into things that you already know how to do. So here's how it works. The factors are the length, and you could say height or width, okay? Pretty much generically, they're the dimensions of the rectangle. We'll call it the length and the height of the rectangle. But you could equally say length and width. A generic term for that is dimensions. So when we talk about the dimensions of a figure, essentially what we mean are the measurements of it, okay? And the product is the area. Okay, so what that would be, if you think back to your previous homework, okay, you have a rectangle, let's say the height is 4 and the width or length is 5, then the area would be 4 times 5, which is 20. And you can see there the factors and the product. Remember, factors are things that are multiplied to give you what's called a product. And so we've got 5 times 4 are the factors, and then the product or the result of that multiplication is the 20, which is the area of the rectangle. So the end goal will be to be given an expression such as 6x squared minus 1x minus 12 and figure out which factors are going to multiply to give you this product. And eventually we're going to use that to solve equations. So that is the direction that we are eventually going to go with this. So let's look at how the number 12 could be represented as factors using the area model. So the first one is you could have a rectangle that is 2 units tall by 6 units wide. The 2 and the 6 are the factors. And then the area is 12, which is the product. Okay? And so you could represent 12 that way using a rectangle. Or you could have a 3 by 4. So you could have a a length of 3 and a height of 4. And again, if you count the rectangles, okay, you would have 12 rectangles. Let's just do that just in case no one's ever done this or it's been a while. If you have 2 by 6, you have 2 squares this way, 6 this way, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 rectangles. 3 by 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? And then the last way would be that 1 by 12, and it is covered up by my face, but you'll be able to look at the copy of the notes that's posted online. Okay, and in this one you would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, kind of going underneath the picture there, and we would have that area of 12. Right, that's pretty much how the area model works. And I want you to keep coming back to the idea of area. Try to avoid calling it a rectangle method or a box method. Like what we're doing is we're talking about area, okay? Not necessarily boxes. I mean, that's what a rectangle can look like. I get it. But what we're doing here is we're finding the area. So we're going to review how this works with multiplication. If you think back to your elementary school, you learned how to multiply before you learned how to divide. So we always start in the direction that's easier to work with. So this also ties into your homework. If you have x plus 3 and we want to multiply that by x minus 2, you could represent that on a rectangle like this. Oh, wait a minute, not like that. Don't make it a 12 because it's not. Okay. And what we do is we think of this as being one large rectangle that's comprised out of 4 smaller rectangles. And what we're going to do is find the area of each of those rectangles. Now, remember that these rectangles are not drawn to scale. Okay, so for convenience, the 3 and the 2 might look the same. Okay, or that, yeah, just kind of roll with that. It's not necessarily drawn to scale. So this first rectangle has a height of x and a length of x. And then we know that area is base times the height, or we'll say length times the width, or length times the height. It's the 2 dimensions. And so we would have x times x, which would give us x squared. In my second rectangle, we have a height of x coming from over here and a length of 3. So the area of this rectangle would be x times 3, also known as 3x. Here we have a length of x, and this time the height is -2. Now that might mess with you a little bit. You might say, wait a minute, height can't be negative. Yes, I know. Roll with the idea here that, like, just to say we could have something called negative area. And you can, in some contexts, like area below the ground might be negative and above the ground might be positive. Okay, so you could think of it that way. We have a length of x and a height of -2. So the area would be base times height, which is -2 times x, or -2x. And then this rectangle has a length of 3 and a height of -2. Area is length times width, base times height. And so this would be 3 times -2, which is -6. Now, remember that we're looking for the area. All right. Now, this is not what we have here is not the area of. Shoot, I don't have my watch. I don't have my watch on to tell me what my phone is doing. So I apologize. Hang on a second. Okay, I had to take care of that. I apologize. So what we have here is the area of the whole thing. In order to find the area of the whole rectangle, what I need to do is add up the areas of the smaller rectangles. So that would be x squared plus 3x plus -2x plus -6 or -6. And so it would look like this. We'd have x squared plus 3x minus 2x minus 6. And then if you recall from Algebra 1, you can combine what are called like terms, which means you can combine x squareds with other x squareds or x's with other x's. And so 3x minus 2x is 1x, and we have -6. Now, over here on the right, okay, I have what are the factors here and what is the product, because we want to bring it back to factors, product, length and width, area, and so forth. So in this example, the factors are the x plus 3 and the x minus 2. Often you'll see them in parentheses, okay, and that just groups them together. And what is the product? It is x squared plus 1x minus 6. And you don't have to put the 1 there, okay? You don't have to put the 1 there. All right, so what I want you to do right now is pause the video and try this one out, okay? So you try this one, and then what are the factors, and then what is the product? It's underneath my head, okay? And try to work that one out on your own. All right, let's take a look at what this one would look like. So we draw out our rectangle, and we've got 2x and 1. and then we have x and 7. And then what our strategy is we're going to find the area of each of the smaller rectangles and then add them up to get the area of the big rectangle. So if you have 2x times x, okay, that's 2x times x. And I'm just doing a little scratch work there down on the lower left. X times x is x squared. So 2 times x would give me 2x squared. 1 times x is just x. 2x times 7 is 14x. And then 1 times 7 is 7. And then in order to get the area of the whole thing, we would have to add those up. And so 2x squared, and then we'd have x plus 14x, which would give us 15x plus 7. And then to bring that back to the vocabulary, all right, sorry about that too. It's like really bugging me now because I just made it worse. There we go. What are the factors here? Well, the factors were the 2x plus 1 and the x plus 7. And what is the product? The product was this right here. Okay, so that's the product. Okay, so that's how it works with multiplication. So where are we going with all of this? I'm glad you asked. In factoring, we will do this process backwards. So we are going to start with something that looks like this and work our way backwards. Now, we are going to kind of ease into this. We're going to start by filling in the blanks, and then eventually you're going to do this on your own, and we'll talk about how to do it and everything. So suppose I have x squared minus 2x minus 48. Okay, so what we need to do is figure out what would go in those other boxes. Okay, and you might be wondering some things, and hopefully when I do this in class, people are going to ask, and we'll get to it. So you might see where the minus 48 came from. What you probably can't tell is where the minus 8 came from. So you can kind of stare at that, and you should be asking that question. You should be looking at it and saying, I don't know where that came from. We will get to it. For now, because we're starting by filling in the blanks, you're just going to kind of sit on it. So if you think back to the other ones that we've done, we've had like x and gotten the x squared. So if you're thinking to yourself, okay, that's probably the x squared, you would be right. Now, here's where it gets a little bit tricky. You can see the x squared. You can see the negative 48. That's a little bit of a mystery, but we know that the area of the entire rectangle is x squared minus 2x minus 48. We got the x squared. We have the minus 48. We need a minus 2. But we have a minus 8. All right, so let's see if we can reason out what's happening there. We need minus 2x. We have a minus 8x. So what you need to ask yourself is what would go there in order to get the minus 2? Because remember, you'd add them together. Okay, so that's how it worked in the other ones where you would add them together. So you can do this a bunch of different ways. I am not going to lock you into one way of thinking about it or processing it. But for a lot of students, this works pretty good. Negative 8x plus what equals negative 2x. Okay. Kind of, at least that's how I think of it. Okay, that's how my brain processes it. Yours might be different, and that's okay. So negative 8x plus what would give me that negative 2x? So we would add 8x to both sides. Now, if you're wondering, like, why did she add 8? There's like a minus sign. Well, because negative 8x plus 8x is 0, okay? That would be equal to 0, and that would make it cancel out. And so my question mark is negative 2x plus 8x. Negative 2 plus 8 is 6. And so this would be a 6x. Now, before we go on, before we look at it anymore, just I want you to pause and think through this and make sure that this makes sense to you. If you take x squared minus 8x plus 6x minus 48, that would give you the area of the whole thing. And the negative 8x plus the 6x is where the negative 2x comes from. So now you just need to figure out what's the length and what's the height. Well, if you've got x squared here, probably that came from x times x. So let's go ahead and fill that in. That was probably x and x. And then moving down here, x times something had to give you 6x, so that must be a 6. And if you look over here, x times something had to give you negative 8x, so hopefully that was a negative 8. And then you actually have a check built in. This rectangle down here should be 6 times negative 8, which would give you negative 48, and it works. If you have, like, let's say a 6 here, and you do 6 times 6, and you get a number that doesn't match, then that can't be it. So remember what we were doing. We were starting with the area, and then we were working our way backwards and finding, well, what's the length and the width of the rectangle? Well, the length is x minus 8, and the width would be x plus 6, because that's a positive 6. So there's my answer, x minus 8 and x plus 6. And you could work that problem backwards by putting it into a rectangle and multiplying it and seeing, oops, sorry about that, and seeing if you got that answer. Okay, now if you need to, rewind this part of the video and just kind of walk through that again. Okay, especially this process over here, like, what do I need? What do I have? How do I get there? And if that particular process didn't make a whole lot of sense and you can kind of see it a different way, that's completely okay. All right, let's take a look at another example. Ooh, all right. So this time we're given the top two boxes, and we know the area. We know the area of the whole rectangle is 3x squared plus 14x plus 8. And what we're looking for is what's going to go across the top and down the side. Now, to do that, we have to figure out what goes in the other box. So now, if you look at the patterns from before, you always have the x squared. This one was always just a number, and then the x's went along the diagonal. So our thought process is we need a 14x. What do we have? Well, we have a 12x. And again, you're probably wondering, where did Mrs. Taylor get the 12x? We will talk about it. Okay, coming in a future lesson. In fact, it'll kind of hit you at the end of this one, but not yet. So we have 12x. So what would have to go here? Well, it would have to be a 2x. Okay, that would have to be a 2x there. And then the 2x plus the 12x would give us the 14x. And then that means that this must be the 8. All right. So what do we got? All right. So we need to figure some stuff out. Let's start with the 3x squared. So 3x squared. Okay, we know probably now you could try to do something like this. Okay, I'm just gonna, don't write this down. All right, so if you're taking notes at home, don't write this down. So 3x squared is 3 times x times x. So somebody might do this. They might say, well, I'm gonna break it up into 3 and then times x squared. The problem with doing that is that when you try to multiply to get this area, see how you've got the x squared? Okay. you've got this x squared, and you don't want an x squared there. So whatever that is going to end up making this being something x squared. And that will always happen. So if you don't believe me, you can keep trying to do that, all right? But it's always going to happen. So the way you have to break it up is x squared, 3x, and then an x by itself. So I'm going to go ahead and put, I guess we'll put the 3x here and the x here. And you might be saying, well, how do you know it's not the other way around? I don't, but we're just going to roll with it. Okay. So let's see. And it might not matter, okay? Because like you could take a rectangle and you can like turn it around, same rectangle, right? Just turn differently. So let's look at this one right here. We have x times something to get the area. So that should be to give us 2x. So this would have to be a 2 right there. Okay. And then you can do this any way you want. You could do 2 times something right here would have to give you 8. So 2 times what would give you 8? That would be 4. And then whatever box is your last one, you can use that to check your work. So 3x times 4 better give me 12x because that's what I have in the box, and it does. And so we end up with the factors x plus 4, and then going down the side, 3x plus 2. Okay, now let's just go back quickly and address that question of, well, how did I know that this had to be like 3x here and x here? Well, let's just see what would happen if I had done it differently. Okay, so let's just see how that would have worked. So let's say I had put the 3x right here and the x there. Okay, so let's see. So then, okay, it's going to run into a problem. So you can start here, okay, and you can do x times what would give you 12x. And so you start putting the 12 there. But now it just gets really, really messy. So 12 times what would give you 8. All right, now remember I said that like we're not dealing with decimals and fractions, and so 12 times something would give you 8 would have to be a fraction, and it wouldn't work. So now when we get to some of the other problems, I am going to show you a way to do that so that you won't have to worry about it. 2 times 4, okay. So you wouldn't have to worry about it. Like there is a way that you can reason that out just using a GCF and finding the greatest common factor, and you wouldn't have to worry about making that mistake. All right, now the other question that students might ask is this: does it matter which one of these comes first? Like, so could you, let's say you're doing your problem and you write 3x plus 2 on the left and then the x plus 4, would you also have it correct? And my answer to that question is, all right, well, suppose I write 2 times 3 and you write 3 times 2. Are those the same? Why, yes, they are both equal to 6. So it's the same deal. You're writing two things that are being multiplied. It does not matter which order you write them in. All right. So any of these problems, if you write them one way and I write them the other way, doesn't matter, okay, because you're just going to multiply them anyway. All right. So let's move on to the next piece of this lesson. Everybody does need a Desmos account. Some of you have already signed up for one. I was going to use a Desmos activity earlier in the year, and I had projected up on the screen, sign up for Desmos, and some of you did, and then we ended up not getting to that activity, so it wasn't an issue. But this time I do want to assign stuff, and the reason I want you to have an account and I don't want you to do it on a guess code is if you stop partway through on a guess code, you lose all of your work. So you would, and then you want to finish it, you would have to start over from the beginning. And I don't want anybody to have to do that. So you're going to go to https://student.desmos.com and use the class code listed for your class period. You're going to do activity 1A as classwork and activity 2A as homework. And I will release that homework to you once we have gone over the classwork. Okay, so I don't want you jumping ahead and doing both. Now, what's going to be great about that Desmos is it's going to check you along the way. Okay, it's going to be fill in the blank, and it's going to put up a green check mark if you did it correctly, and it's going to give you a red X if it's not correct. So you're going to know if you did it right. Please do not just do guessing, okay? Like try to reason your way through it, all right? And then what we'll do is we'll talk through it in class, and then I'll release activity 2A to you to do for homework. As you are working, I want you to consider these questions. What patterns do you notice about what goes in the upper left box? You may have already noticed some patterns, okay? What patterns do you notice about what goes in the lower right box? And then what do you think will be the most challenging parts of filling in the boxes? And there should be a question mark after that. There, that's better. Okay, now notice I didn't ask you, I asked you about that one, upper left, and I asked you about that one, lower right, and I did not ask you about those two. Might be a little bit of a clue about that third question, and it also goes back to, well, where did Miss Taylor get that 8x from? Or the negative 8x, okay, is like filling in those boxes. So all right, so if you are doing this from home, what you need to do is go sign up for Desmos and then do the classwork and the homework, okay? And let me know if you have questions, okay? I know this lesson is a little bit challenging, so I expect to have questions. You're not going to upset me by asking questions, right? And I will see you in the next lesson.